Think about the last time you listened to the radio. Was it a moment of solitude, or were you sharing the experience with someone else? The radio has a unique way of connecting us, whether we're alone or in a crowd. Perhaps you were in your car, stuck in traffic, the hum of engines around you, and the radio providing a soundtrack to your journey. The familiar voices and melodies can turn a mundane commute into a personal concert, or a thought-provoking discussion. Or maybe you were relaxing at home, a warm drink in hand, the radio softly playing in the background. It can be a source of comfort, a companion that fills the silence with stories, music, and news from around the world. As the music, news, or talk show filled your ears, did you ever stop to wonder about the invisible force connecting you to the world? This unseen medium, carrying voices and sounds across vast distances, is a marvel of modern science. Radio, despite its seeming simplicity, is a testament to human ingenuity, a triumph of scientific understanding that has transformed the way we communicate. From the early days of crackling transmissions to today's digital clarity, radio has evolved, but its essence remains the same. Radio waves, unlike sound waves that require a medium like air or water to travel, can traverse the vast emptiness of space. This ability to move through the vacuum of space has opened up incredible possibilities for communication and exploration. This remarkable property has allowed us to send signals across continents, communicate with astronauts orbiting our planet, and even send messages to distant spacecraft exploring the far reaches of our solar system. And it's not just about communication. Radio telescopes allow us to listen to distant stars and galaxies, their secrets whispered to us across unimaginable distances. These cosmic messages help us understand the universe and our place within it. The story of radio is a story of scientific curiosity, groundbreaking discoveries, and the enduring human desire to connect and explore. From the first experimental broadcast to the sophisticated networks of today, radio has been a constant companion in our journey of discovery. From the crackling static of early transmissions to the crystal-clear digital audio we enjoy today, radio has come a long way. Yet the magic of tuning into a broadcast, of hearing a voice or a song from miles away, remains as enchanting as ever. But the basic principles remain the same, harnessing the power of invisible waves to transmit information, entertainment, and knowledge. This invisible ocean of sound continues to be a vital part of our lives, connecting us in ways that are both profound and practical. Join me as we delve into the fascinating world of radio, exploring the science behind this ubiquitous technology and its profound impact on our lives. We'll uncover the history, the technology, and the future of radio, and celebrate this remarkable achievement of human ingenuity. The story of radio begins not in a laboratory filled with wires and flashing lights, but in the mind of a Scottish physicist named James Clerk Maxwell. Born in 1831, Maxwell was a prodigious talent from a young age, showing an early fascination with the natural world and its underlying principles. His curiosity led him to study at the University of Edinburgh and later at Cambridge, where he would lay the groundwork for his future discoveries. In the 1860s, Maxwell developed a set of equations that elegantly described the relationship between electricity and magnetism. These equations, known today as Maxwell's equations, unified the previously separate fields of electricity and magnetism into a single theory of electromagnetism. This was a monumental achievement, as it provided a comprehensive framework for understanding how electric and magnetic fields interact and propagate. His groundbreaking work predicted the existence of electromagnetic waves, ripples of energy that could travel through space at the speed of light. This was a radical idea at the time, as it suggested that light itself was an electromagnetic wave. Maxwell's equations implied that these waves could travel through the vacuum of space, carrying energy across vast distances without the need for a physical medium. Maxwell's theories were nothing short of revolutionary, but it was up to others to prove their existence. His work laid the theoretical foundation, but experimental validation was still needed. This task would fall to the next generation of scientists, who were inspired by Maxwell's visionary ideas and determined to test them in the real world. In 1887, German physicist Heinrich Hertz took up the challenge. Hertz was a meticulous experimenter, known for his precision and attention to detail. He designed a series of experiments to generate and detect electromagnetic waves using a spark gap transmitter and a receiver. His work was meticulous and methodical, and after many trials he succeeded in producing and detecting these elusive waves. Hertz designed an experiment using a spark gap transmitter and a receiver to generate and detect electromagnetic waves, confirming Maxwell's predictions and paving the way for the development of radio communication. His experiments provided the first concrete evidence of electromagnetic waves, demonstrating their existence and properties. This was a pivotal moment in the history of science, as it validated Maxwell's theoretical work and opened up new possibilities for communication technology. Building upon Hertz's discoveries, Italian inventor Guglielmo Marconi developed the first practical radio system. Marconi was a visionary inventor, driven by the dream of wireless communication. He saw the potential of Hertz's work and set out to turn it into a practical technology. Through relentless experimentation and innovation, Marconi developed a system that could transmit signals over long distances without the need for wires. In 1895, he successfully transmitted a radio signal over a distance of 2 kilometers, forever changing the world of communication. This achievement marked the birth of modern radio, a technology that would go on to revolutionize the way people communicated. Marconi's success demonstrated the practical potential of electromagnetic waves, and his work laid the foundation for the development of the global communication networks we rely on today. Marconi's invention sparked a revolution, connecting people across vast distances and ushering in the age of wireless communication. The impact of his work cannot be overstated. It transformed society, enabling instant communication across continents and oceans. The pioneers of the airwaves, from Maxwell to Hertz to Marconi, laid the groundwork for the interconnected world we live in today, where information flows freely and instantly across the globe. Radio waves like visible light, X-rays, and microwaves are all part of the electromagnetic spectrum. This spectrum encompasses a vast range of electromagnetic radiation, categorized by wavelength and frequency. Wavelength refers to the distance between 2 successive crests of a wave, while frequency describes the number of waves passing a given point per second. Radio waves occupy the longest wavelengths and lowest frequencies of the electromagnetic spectrum. They range in size from millimeters to kilometers, traveling at the speed of light, which is approximately 300,000 kilometers per second. These waves, invisible to the human eye, carry energy and information, making them ideal for communication over long distances. The different properties of various electromagnetic waves allow them to be used for a wide range of applications. We use X-rays to see inside the human body, microwaves to heat our food, and visible light to illuminate our world. Radio waves, with their ability to travel long distances and penetrate obstacles, have become essential for broadcasting, communication, and navigation. At the heart of radio communication lies the process of modulation, a clever technique that imprints information onto radio waves. This process is fundamental to how we send and receive information wirelessly, whether it's music, news, or even data for our smartphones. Without modulation, radio waves would be like a blank canvas, devoid of any meaningful content. Imagine a radio wave as a blank sheet of paper. Just as a blank sheet of paper holds no information until something is written on it, a radio wave needs to be modulated to carry any useful data. This analogy helps us understand the importance of modulation in radio communication. To transmit information, we need to write on this paper, and that's where modulation comes in. By varying certain properties of the radio wave, we can encode information onto it. This is akin to writing a message on a piece of paper, making it readable to anyone who understands the language. There are 2 main types of modulation: amplitude modulation, AM, and frequency modulation, FM. Each type has its own unique way of encoding information onto the radio wave, and both have their own advantages and applications. In AM radio, the amplitude or strength of the radio wave is varied to carry the audio signal. This means that the height of the wave changes in accordance with the sound being transmitted. AM radio is often used for talk shows and news broadcasts because it can travel long distances, especially at night. It's like changing the intensity of a flashlight beam to represent different sounds. When the sound is louder, the beam is brighter. When the sound is softer, the beam dims. This visual analogy helps us grasp how AM radio works. FM radio, on the other hand, varies the frequency of the radio wave to encode the audio information. Instead of changing the height of the wave, FM changes the distance between the waves. This method is less susceptible to interference and provides better sound quality, making it ideal for music broadcasts. Think about changing the color of the flashlight beam to represent different sounds. Each color change corresponds to a different frequency, just as each sound in FM radio corresponds to a different frequency modulation. This makes FM radio perfect for delivering clear and high-fidelity audio. Once the radio wave is modulated with the desired information, it is amplified and transmitted from an antenna. The antenna plays a crucial role in broadcasting the signal over vast distances, ensuring that it reaches radios and other receivers far and wide. This antenna acts like a loudspeaker, radiating the radio waves outward. Just as a loudspeaker projects sound into a room, the antenna projects radio waves into the air, allowing them to travel through space and reach receivers. At the receiving end, another antenna captures these waves, converting them back into electrical signals that are then demodulated to extract the original audio or data. This process is akin to reading the message written on the paper, allowing us to hear the music, voice, or data that was transmitted. The seamless journey of these signals through the air is a marvel of modern technology, connecting us in ways that were once unimaginable.